Hi students, today we'll be doing a short recap on the homologous series of carbon compound that you have learned in Form 5 Chapter 2, Carbon Compounds. So let's start. Right, so over here you can see that I've made a very short table to summarize the key points regarding the 5 homologous series that you have learned. So we start by recapping what are the 5 homologous series that we have covered in Chapter 2 from 5 SPM syllabus. So the first homologous series that you learn is the alkanes group, all right? So we do a quick recap. Alkanes, they are consider the saturated hydrocarbon. All right. Now, the word hydrocarbon suggested that the members of alkanes is only made up of hydrogen and carbon only. There's no other elements that's used to make up alkane. So alkane, remember, it's only made of hydrogen and carbon only. Now, the word saturated suggested that all alkanes are bonded by single bond between carbon atoms, right? So that is the first homologous series. Now, following that, the next thing that you learn is called alkene, all right? Now, alkene, on the other hand, it is an unsaturated hydrocarbon. Right, it's still a hydrocarbon. That means to say members of alkene, it's still made up of hydrogen and carbon only, but unlike alkane, which is saturated, alkene is unsaturated, which means to say you expect to see the presence of double bond between carbon atoms in alkene. All right, so alkane, the first homologous series, followed by alkene. Then the next homologous series that you learn is alcohol. All right, alcohol group. Now, alcohol is not a hydrocarbon, all right, because if you remember the formula, members of alcohol is made of carbon, hydrogen, and oxygen. So because of the addition of oxygen, it makes it a non-hydrocarbon. So then you also learn the next homologous series. You have the carboxylic acid. Right? Carboxylic acid, just like alcohol, it is made up of carbon, hydrogen, oxygen, and that makes it a non-hydrocarbon. And the last homologous series that you learn is called ester. All right, ester, which is also a non-hydrocarbon due to the presence of oxygen. Now, ester is formed when you have alcohol reacts with carboxylic acid. All right, so this is when the alcohol reacts with carboxylic acid, the product that it forms is called esters. Now, so these are the 5 homologous series that you have learned under Chapter 2, and all you understand is that each of these homologous series, right, they have a list of members inside. Right, they have the list of members inside, and for each homologous series, they have their own general formula, they have their own functional group, they also have very different physical and chemical properties. All right, so we do a quick recap regarding the first homologous series, alkane. So members of alkane, all of them follow the general formula of CnH2n plus 2, CnH2n plus 2, where the n starts from 1 onwards. So when I put n starts from 1 onwards means the first member has 1 carbon. All right, second member has 2 carbon, third member has 3 carbon, so on and so forth. All right, now all the members of alkanes, they basically do not have a very obvious functional group. All right, so next we look into how do we name the first few members of alkane. Now when you want to name the members of alkane, remember the name of each member consists of 2 parts. There's one part that is deduced from the carbon that it contains, and the other part deduced from the homologous series that it belongs to. So if you look at the first member has 1 carbon, so the name for the first member, the first part of the name is called meth, right? Now, any carbon compound that has 1 carbon, the name will always start with meth. And because they belong to alkane group, they will end with the name of ane. So the first member is called methane. Now, second member with 2 carbon, carbon compound with 2 carbon, their name starts with eth. All right, so eth suggested that it has 2 carbon, and it ends with ane because it belongs to the alkane group. Right, third carbon, the third member has 3 carbon. So those carbon compound that has 3 carbon, we start with the name of prop. Right. So prop suggested that it has 3 carbon and it ends with ane because it belongs to the homologous series of alkane. So of course you have the next member will have 4 carbon, we call it butane, 5 carbon, pentane, so on and so forth. Right? So now let's discuss what are the physical properties of alkane that you have learned under chapter 2. The first thing is all members of alkane, they have low melting point and boiling point. All right, due to the fact that they are bonded by the weak van der Waals force of attraction. Right? So some students will ask teacher, why is it they are bonded by weak van der Waals force? The reason is because alkane molecules, so all the members of alkane is either made of carbon and hydrogen. Carbon is non-metal, hydrogen is non-metal. So in fact, alkanes are covalent compound. So just like other covalent compound, they are bonded by the weak van der Waals force, and due to that, they have a low MP and BP. Now, secondly, all members of alkane are not soluble in water, but instead they are soluble in organic solvent. Right? On top of that, all members of alkane cannot conduct electricity regardless which state it is in. Right? See. Okay, so these are the general physical properties of alkane. Now, let's look at what are the chemical properties. So guys, when we discuss chemical properties means we are looking into what are the chemical reactions that members of alkanes can undergo. Now, all members of alkane will be able to carry out combustion reaction. Combustion reaction when you burn them in excess of oxygen. All right, so if you have a complete combustion, you will always produce carbon dioxide, CO2, and water, H2O. All right. Now, besides combustion, alkane can also undergo substitution reaction. All right. It can undergo substitution reaction with chlorine, halogen to be more specific, chlorine and bromine. All right. It can undergo substitution reaction with chlorine and bromine. Right, so, but this substitution reaction, right, do not happen naturally. You need the presence of UV light in order for substitution reaction to take place, right? So alkane only can carry out these 2 types of chemical reaction. Okay, right. So with that, we are done with a very quick summary on alkane. Now we shall move on to the next homologous series, which is alkene. Now, even though the name is pretty much the same like alkane, but alkene, the second homologous series, has a very different general formula, very different chemical properties. So let's start by recapping the general formula. Now, some members of alkenes, right, they follow another general formula of CnH2n. So unlike alkane is CnH2n plus 2, homologous series of alkene, members of alkene will follow CnH2n. So comparatively, members of alkene will have less 2 hydrogen compared to the members of alkane. Right, and for alkene, you can see N starts with 2, which means to say the first member starts with 2 carbon, then the second member has 3 carbon, then followed by 4 carbon, so on and so forth. Right, so all members of alkene, unlike alkane, there's no obvious functional group. Members of alkene has a very obvious functional group, which is the double bond between carbon atoms. So all members of alkene, you can see that there's a presence of double bond between the carbon atoms. Right? Okay, so let's try to recap the naming for the first few members of alkene. Remember, as I've mentioned just now, when you want to name an organic compound, right, the first name is always deduced from the number of carbon that it contains. So since the first member has 2 carbon, so the name will start with it. And because it belongs to the family of alkene, it will end with the name of in. So if it's due to the two carbon inside, and it ends with in because it belongs to the homologous series of alkene. So the third member, the second member with 3 carbon is prop, all right, and it ends with the name of in. Prop is because it has 3 carbon inside. Next, the next member has 4 carbon. So those with 4 carbon, the name will start with bute, all right, and it ends with in. Okay, so that is so on and so forth. Now next, how about the physical and chemical properties of alkene? So basically alkene, just like alkane, it is only made of carbon and hydrogen. Therefore, it will have the same physical property as members of alkane. All right, so the physical properties for members of alkane and members of alkene will be the same. All right, but however, the chemical properties is very, very different. So let's look at what are the chemical reactions that members of alkene can undergo. Number one is combustion. All right, basically all type of organic compound that will be able to carry out combustion. So when you burn them in excess oxygen, you will have a complete combustion. And when there's complete combustion, you will form CO2 and H2O. All right, this is exactly the same like alkane. Now, then the second chemical properties, unlike alkane, due to the fact that it is very saturated, it can only carry out substitution reaction, means replacement. But for alkene, due to it being unsaturated and due to the presence of that double bond, it makes it very, very reactive. It can carry out various addition reactions. All right, so it can carry out a series of addition reactions. Now, as the name suggests, right, addition reaction means you add in something into alkene. And there are many things that we can add into alkene. For example, the first one, you can add hydrogen into an alkene. So when you add hydrogen or H2 into an alkene, the process has a specific name called hydrogenation. And when you perform hydrogenation of alkene, you will turn it into alkane. You form alkane at the end of the day. Now, for example, let's say if I got ethene, when I add hydrogen, I will get ethane. All right. Now, next, another example, let's say we have the second member with 3 carbon, propene. So propene, if I perform hydrogenation or I add hydrogen into it, it will turn it back to propane. All right. So when, again, the key idea over here is that when you perform hydrogenation, you will turn alkene back to alkane. So that is one thing, the first thing that we can add into alkene. Now, besides hydrogen, we can also add water to alkene, right? And this process has a specific name. We call it hydration. Add water in it. And what happens is when you perform hydration on alkene or when you add water to an alkene, you will turn it into alcohol. For example, if I have ethene, I add it with water, I expect to get ethanol. If I have propene and I perform hydration by adding water, I will get propanol. All right, so what else can be added? Now, besides hydrogen and water, we can also add halogen inside. And when you add halogen inside, the process has a specific name. We call it halogenation, right? It's called halogenation. Now, so this halogenation process is different from the substitution with chlorine and bromine of alkene. It's very different. Halogenation do not need UV. Halogenation of alkene do not need UV light. Right, what else we can add in? We can add hydrogen chloride inside or any hydrogen halide. For example, we can add hydrogen fluoride, hydrogen chloride, hydrogen bromide. We can add all this thing inside your alkene. All right. You can also add on with hydroxyl group into your alkene. This process has a specific name. It's called oxidation. All right. Last but not least, you can add with other smaller alkene. This process is called polymerization. All right. So what do I mean by adding a smaller alkene? For example, you can have ethene, add with ethene 1, add with another ethene, add with another ethene, add with another ethene. All right. And that process is called polymerization. All right. So these are the few things that we can add into alkene. All right. So out of the few addition reaction, the one that's quite common in SPM is usually the first one, hydrogenation. And then hydrogenation is very popular. Hydration also very popular. Okay, and then addition of hydroxyl group, oxidation process is very popular. Polymerization process is also very popular. So you need to be able to study in detail how to write the equation involving hydrogenation, hydration, oxidation, and polymerization. All right. So take note for both hydrogen and hydration process. These two processes do not occur naturally. It needs help. You need to provide a specific condition for it to occur. So now we will look into what are the specific conditions needed for hydrogen, for hydrogenation. So to perform hydrogenation, you need the help of nickel as catalyst, and also you need to have a slightly higher temperature of 180 degrees Celsius so that hydrogenation can occur optimally. All right. Now, as for hydration, this one also needs specific condition. Hydration, you will need phosphoric acid. Phosphoric acid with the formula H3PO4. You need it as catalyst, right? On top of that, you will need a much higher temperature, 300 degrees Celsius, and also temperature of 60 atm in order for hydration to take place successfully. So please be reminded of the specific condition needed for both hydrogenation and hydration process. Okay. All right, so with that, we have done with a very quick recap on alkene. So we shall move on to the third homologous series. We have the alcohol group. Now, members of alcohol, like what I've mentioned just now, they are non-hydrocarbon due to the fact that there's presence of oxygen inside. Now, members of alcohol will follow a new general formula, CnH2n plus 1OH, all right, whereby OH will be the functional group. OH, or we call it the hydroxyl group, is the functional group for all members of alcohol. Now, from the list over here, what you can see is that, down here. So the list over here, you can see N starts from 1 onwards, which means to say the first member of alcohol has started with 1 carbon. Next member, you have 2 carbon. Then you have 3 carbon, so on and so forth. Right? So now let's try to name the first 3 members. Now, again, the naming is pretty much the same. The first part of the name is deduced from the number of carbon that it contains. So the first member has 1 carbon, so it starts with meth. And because it belongs to the homologous series of alcohol, it will end with name with anol. So it's called methanol, right? So meth. Second member will start with eth, and it ends with or, so it's ethanol. Third member, propanol. It starts with prop to suggest that it has 3 carbon, and you end with or to suggest that it's from the alcohol group. Okay, right. So alcohol group, this one, physical properties that you need to remember. Number 1, it will burn with blue flame, right? Number 2, it is soluble in water. Soluble in water. Okay, so the key physical property that you need to remember under alcohol would be it will burn with blue flame, and it's normally very soluble in water. Right, next we discuss what are the chemical properties or chemical reactions that alcohol can undergo. Number 1, just like your alkane and alkene, your alcohol is able to undergo combustion reaction. And when you perform combustion reaction and you burn it in excess oxygen, you will form carbon dioxide and water as usual. Now, besides combustion, alcohol will be able to carry out dehydration reaction. So the word dehydration suggested that we remove H2O, water, from them. So yes, you can remove H2O from alcohol. When you perform dehydration on alcohol, you will actually turn it back into the alkene group. For example, if I have propanol, and when I perform dehydration, so that when I perform dehydration on propanol, which means to say I remove water from propanol, so that will turn propanol back propene. Another example, let's say if I have ethanol, all right, so when I remove water from ethanol, it will turn it back into ethene. All right, now please take note, dehydration process is not applicable for the first member, ethanol, yeah? Other than that, all other alcohols will be able to carry out dehydration process. Okay, next, moving on. Besides combustion, dehydration, what else reaction that alcohol can undergo? The third one is called oxidation. So to perform oxidation on alcohol, normally we will let it react with specific reagent, acidified potassium manganate, KMnO4, or acidified potassium dichromate 6, K2Cr2O7. All right. So if you want to perform oxidation on alcohol, you will either let it react with acidified potassium manganate 7 or acidified potassium dichromate 6. Now the product of oxidation is you will form carboxylic acid, which means to say, for example, if I have propanol and I perform oxidation, I will get propanoic acid. If I have ethanol and I perform oxidation, I will get ethanoic acid, so on and so forth. All right, so these are the three chemical properties of alcohol, right? Combustion, dehydration, and oxidation. Right, so moving on to the next homologous series, we have carboxylic acid. Same, just like alcohol, carboxylic acid is non-hydrocarbon. Again, why is it non-hydrocarbon? Due to the presence of oxygen inside. Now, members of carboxylic acid will follow general formula of CnH2n plus 1 COOH, where the N starts with 1 onwards, which means to say the first member has 1 carbon, followed by the second member with 2 carbon, so on and so forth. Now, for all members of carboxylic acid, they have a specific functional group, COOH, or we call it the carboxyl group. Carboxyl group. So this is a functional group for all members of carboxylic acid. Right, now let's try to name the first 2 members of them. First carbon, so it's called methanoic acid. Right, second member is called ethanoic acid. So if we add 1, the third member with 3 carbon is called propanoic acid, so on and so forth. Right, so carboxylic acid, I think there is one physical property that you need to know. It is soluble in water. It is soluble in water. Okay, now we focus more, basically for alcohol and carboxylic acid, right? We focus more on the chemical properties, right? So carboxylic acid, all the members of carboxylic acid, what are the chemical reactions that it can undergo? Now you see, when we look at this homologous series, right, carboxylic acid, they are actually under the roof of acid. They are acid, and in fact, carboxylic acid are weak acid. All right, compared to your HCl, H2SO4, HNO3, those acids are strong acid. But carboxylic acids, all of them, all the members of carboxylic acid are considered as weak acid. So a quick recap, weak acid is defined as acid that only ionize partially in water, produce low concentration hydrogen ions, right? So all carboxylic acid are weak acid. Now, Even though they are weak acid, but they're still under the roof of acid, right? So they will have exactly the same chemical reaction like any other acid. For example, they can react with matter, reactive matter. They can react with reactive matter, and when that happens, right, it will produce salt and hydrogen gas, H2. All right, it will produce salt and hydrogen gas. So the example of reactive matter that is commonly reacts with acids are zinc, magnesium, so on and so forth. Now, besides ability to react with matter, carboxylic acid can also react with base or alkaline. And I'm sure all of you know what is the name of this reaction. So when they react with base and alkaline, they will produce salt and water, H2O. Right? This process is also called the neutralization process. Now, the other one, carboxylic acid is also able to react with metal carbonate. Just like all other acids, it can react with carbonate. So when it reacts with carbonate, it forms salt, carbon dioxide, CO2, and water, H2O. All right, so in fact, all types of acid, be it strong acid, weak acid, all types of acid can have these three reactions. Reaction with reactive matter, reaction with base on alkaline, or reaction with metal carbonate. Right, so these are the three reactions that you have actually learned under Form 4 syllabus. All right, okay, now, besides these three reactions, carboxylic acid is also able to react with alcohol to form ester and water. Right, now reaction 4 is the one that is specific only for carboxylic acid. All right, other acids that you have learned, for example, hydrochloric acid, sulfuric acid, normally they do not react with alcohol to form ester. All right, so this one is specific only for carboxylic acid. All right, but the other three, the top three are the common reactions of acids. All right, so we are done with this, and now we look into the last homologous series, which we call it as the ester. Now, esters are formed when the alcohol reacts with carboxylic acid, and the process formation of ester is called esterification process. Now, esters, due to the fact that it's derived from both alcohol and carboxylic acid, you can see that its general formula is quite long. All right, but anyway, just to break down and show you, this part of the general formula of ester is actually deduced from alcohol. All right, the one that I highlighted in green, this part is actually deduced from alcohol, and the one that I'm highlighting in yellow is the part that's deduced from carboxylic acid. So this one is deduced from carboxylic acid, and the green part is deduced from alcohol. Okay, right. So we have many members of esters, right? I think for esters, right, the main thing that you need to know would be how to name the esters, how to draw them out, what are the physical properties of ester. All right, so we do a quick recap. So normally we do not name members in sequence. We name esters based on which alcohol and which carboxylic acid that we use to form them. So if I have time, I'll produce another video to teach you on the naming, specific naming for members of ester. All right, so for ester, for today, we'll be focusing on the physical properties of ester. Number one, when we talk about esters, right, these are the group of carbon compound that has fruity smell or very fragrant smell. All right, they are normally not soluble in water, except this member called methyl methanoate. Except methyl methanoate. All right. Now, as for chemical properties, we actually don't cover it under SPM syllabus. Okay, so with that, we have done a very quick summary regarding the basic things that you need to know about the 5 homologous series. Right? Okay, so with that we are done. Now next, we will just move on with some interconversion of homologous series. Now even though from what you have understand previously, we have 5 homologous series. Each of them have their own list of members, have their own physical properties, have their own chemical properties. But please bear in mind, these homologous series are interconvertible. Right? One homologous series can turn into another homologous series through specific chemical reaction. And this is what we're going to discuss over here. All right. So let's start. So I will need an arrow for it. Hold on now. Okay. Okay, so basically for homologous series, the first one, alkanes, due to the fact that it is very saturated, it is not able to turn into any homologous series. But however, alkene has the potential to turn into other homologous series. Now, alkene will be able to turn back to alkane, right? The first one, alkenes will be able to turn back to alkanes through a chemical process called hydrogenation. That means to say you add hydrogen in it. Okay, so which means to say if I have ethene, when I add hydrogen, it becomes ethane. If I have propene, I add hydrogen and I will turn it into propane, so on and so forth. So alkenes are able to convert back to alkanes. Now next, alkene can also turn down to alcohol. It can also turn down to alcohol, and the process involved is called hydration. Hydration means you add water. So when you add water to alkene, you will turn it down to alcohol group. Say for example, if you have ethene, you add water, you will get ethanol. All right, propene, add water, you will get propanol, so on and so forth. Right, so that's how alkene can interconvert. So alkene can convert to the series above it, which is alkane. It can also convert to the group that above below it, which is alcohol. Now next, how about alcohol? Alcohol has the same potential. It can turn back to alkene. It can also turn down to carboxylic acid. Right? So alcohol can turn back to alkene. I'll use another color for it. Alcohol can turn back to alkene. It can also turn down to carboxylic acid. Right? So what are the processes that allow such conversion? Alcohol can go back to alkene when you perform dehydration on it. Dehydration on it. For example, if I have propanol, I remove the water, I will get back alkene. If I have ethanol, I remove the water, I will get back ethene. Next, alcohol can also turn down to carboxylic acid, and that is through a process called oxidation, where you add the correct oxidizing agent into it. And the common oxidizing agent that we use are acidified potassium manganate 7 or acidified potassium bichromate 6. So let's say if I have alcohol propanol, when I perform oxidation, I will get propanoic acid. When I have butanol, when I perform oxidation, I will get butanoic acid, so on and so forth. All right. Now next, carboxylic acid, we don't study about the interconversion of it. Esters also, we don't study about the interconversion. So to summarize, out of the 5 homologous series, the one that can do an active interconversion will be the members of alkenes and also the members of alcohol. All right, so please be reminded about the interconversion, because in your SPM questions, there's a lot of questions involving interconversion. All right, which is normally given in the flow chart. Okay, so with that, we are done with today's lesson about a quick summary on the 5 homologous series and also some idea about interconversion of homologous series. Hope you get something from here. Thank you very much.